Hello everyone. This here is a 5 by 10 grid. And the question of the day is, can you input positive integers, 1 or greater, such that the sum of all the squares, or all the integers in each square, on each row and each column is prime? Seems really difficult at first, doesn't it? Because like primes, it's hard to like standardize primes. We can't really. That's the great mystery with them. So how do we do this? Well, a nice fact about primes, except for 2, is that they're odd. And can the sum of any row or column be 2 here? Obviously not, because every input or every square has to be 1 or greater. So okay, we can just start by looking at, can we just create numbers such that it's the sum of all the squares on each row and column are odd? Spoiler alert, pause here if you want to try it out for yourself before you know the answer. The answer is no, you cannot. And I'm going to show you why. So, if we start out by assuming that all the integers are even, then we would know that all the sums, yeah, exactly, all the sums in each row and column, all of them are even respectively, so everything is just even. Now, if you were to switch, so say we've filled in everything as 0, but I don't have the energy to do that. So here and so forth. Yeah, everything is 0, so therefore everything here is also 0, and these are also, everything is 0. Now, if you were to switch an even number for an odd number, what would happen then? Then you would make the row and the column of that square both odd. So, as I said, if you were to switch one of these, then you would switch the value of the column and the row for a 1. And now, let us consider the sum of all of these, the sum of each row and column. So therefore it would be 1 plus 0, 0, 0, 0, 0, a bunch of zeros plus 1. So this, our sum at this moment would then be 2. And now, as this is kind of similar to another video I did, I can link it in the description if you're interested. And now, if we were to just switch this back to an even number again, we would just reverse everything, of course, so then it would be 0 again. If I were to take a new square, which is not connected to the first square in any way, not in row or column, and switch that to 1, what would happen then? Well, yes, then this would be odd once again, and this would be odd. So therefore the sum, or new sum, would then be 4. And now, okay, say that I switch back to a 0 here. Because we have 0, so we're back at 2 now. If I were to switch one of these two, what would happen then? Now, because switching something from even to odd or odd to even, what matters only is if the column is odd or even, and if the row is odd or even. So we can see it as 4 cases. We have odd, odd, even, even, odd even and even odd. Switching a square that is in an even column and an even row adds 2, right? Because it makes them both odd, therefore adds 2. Doing the reverse, switching a square in an odd row and an odd column, obviously then does the opposite, meaning it subtracts 2. And if we pick a square which has an even column and an odd row, so this square, for example, switching this, what would then do? Well, yes, then it would switch this one, and it would also switch this one, meaning that the net gain was 0. And doing the reverse, which is an odd row and an even column, would then do the exact opposite, just which is still nothing. So just minus 0. So our starting point was a sum which was even. Denote as 0 modulus 2. This is what I've been doing all along. If you haven't caught that, I don't know why you're still here. Okay. And what do we want to achieve? We want to have primes in every row and column, or every row and column to be prime. And since primes are odd, then we want odd, everything here to be odd. And what is the sum? Okay, so they have 10 odds and 5 odds, so that we want 15 odds or 15 ones. And what is that? That is an odd number. So what we can see here is that we're starting out at 0. We can add 2 and minus 1, and we want to get to 15, which obviously won't happen. And as an invariant, we can obviously denote this as the sum. Okay, just the sum is the sum of all the columns and the rows. So it's just sum modulus 2. Because this thing never changes when we add or subtract 0, of course, and it also doesn't change when we add or subtract 2. And we are starting at 0, we want to get at 1, and it never changes. So therefore, it can never be. And we can absolutely not have primes in every row and column. So that was everything. Proof concluded, and thank you so much for watching. Bye-bye.